Hi, this is Mary James with Passive House Accelerator. Thanks for tuning in to this special bonus episode of the Passive House podcast recorded at PhiusCon 23 in Houston, Texas. And a big thank you to Zola Windows for their support of this series. And I am here with Cynthia Suarez. Can you please introduce yourself and tell us a little bit about your work at Uber Green Spaces?
I'm from Houston. I'm an architectural designer. I am also the secretary for the Phius Alliance Council. So I joined Uber Green about 3 years ago. And I originally joined as an architectural designer. And soon afterwards, I was introduced to the woofie modeling. So over time, we've been trying to model different homes in different regions, mainly Houston, Cincinnati, Ohio, a project in Louisville, Kentucky. And so over time, it's been really cool learning the different assemblies of what makes this work for different climates.
Although all of those climates that you mentioned are at least in the warm, hot area, yes?
Well, Houston definitely is really hot. Louisville, Kentucky, I believe they get cold. Same with Cincinnati, Ohio.
Oh, that's true.
Yeah.
Colder there,
Yeah.
for sure. So you're seeing a variety of assembly types that you need.
Yes. Depending what the homeowner wants, whether it's siding, stucco, whether we're insulating underneath the slab or not, the different amounts of insulation that we use on the outside of the control layers, even the types of like how we're addressing underneath the roof. Are we using spray foam? Are we using a different material? Or lately we've been even talking about using rock wool because some clients are more concerned about carbon, although there's probably more discussion about that too. But, some clients want us to use different materials, so we have to investigate, model it, and then see how it performs.
And you mentioned insulation under the slab, and that the need for that varies by climate. Have you had a lot of discussions in your office about that?
Yeah, so we traditionally don't model insulation under the slab in Houston, although even yesterday there was a discussion about that in one of our sessions. So that's something, we'd like to explore further as well. But for sure in Louisville, we insulate under the slab as well as do ICF foundation. And we have a project in Cincinnati, Ohio, where we're using more than 4 inches that we used in Louisville. Now we're doing 6 inches. So it's very interesting what we choose to do for what home. Even looking at projects that have already been constructed and someone wants us to run an energy model on it, that's also like an educational piece to see why their home is performing a certain way and what could have been done differently to get the performance that client was looking for.
That's great. Yeah, it's really probably a little unfortunate for those clients if their homes are not performing the way they wanted to, but great to try and figure out why it's not working.
Yeah, and it leads to more conversation. Like, could we talk to a manufacturer? Could we talk to just getting more people seated at the table earlier? Even here in Houston, sometimes a lot of times we come across other subs that have probably no experience doing Phius or speaking in the terms that we speak in. And so it is very important to kind of get everybody on the same page early and encourage each other to try this.
But speaking of trying new things, yesterday there was a lot of discussion about a design project that you were involved in your student days, which is actually going to come to pass in Houston, which is pretty amazing. I mean, I don't know how many students actually get to see a student project become an actual project. Can you talk about that project?
Yes, that project was led by students from Prairie View, and Prairie View is an HBCU. It has a connection with Houston, although it's not Yes.
HBCU, historically Black
College and University.
Mm-hmm.
Yes. And so it's about 50 minutes away from Houston. It's not necessarily in the Houston area, but a lot of folks in the Houston area do attend Prairie View. So it's really special because I believe it's allowed us to bridge like community with students and showcasing the next generation doing the work. I think that's really, really special. When it finally does get built, just the opportunity for the community to see, look, these students did this, and maybe more projects could come in the future where the community is working with the students. I would really love to see that.
And so this project is called Fly Flat?
Yes.
And it's a duplex? Is that what it is?
So the idea was to create a pocket community. And during our investigation, we realized that there are different organizations that have vacant lots. And these vacant lots can be used for something. And they are intended to be used by the community, but nothing has come forward. So the design intent was to partner with a land bank or a land trust, get some lots, and then create a pocket community on these lots. Some of these lots that are unused are usually awkward shaped or narrow. So because of the lots being narrow, we designed it to be on two lots that are adjacent to each other. And we do have plenty of vacant lots in Houston that are next to each other. So we actually replicated that same template a few times in different neighborhoods, one in Acres Homes, one in Independence Heights, for different competitions. So on two lots, we would have 4 buildings, one iteration of each type of floor plan. So 1 bedroom designed for a young professional, 2 bedroom for maybe an older generation couple, and maybe a 3 bedroom for a family, and a community center, as well as a garden in the center to sort of create walkability. We designed that pocket neighborhood to also have the porches facing each other, so people would be able to kind of look at their neighbor and be able to wave. The site was all permeable, and the community garden and the recreation center were designed to be places where the neighbors could gather, learn, or host it for like parties, as well as house the backup battery storage for the solar panels that were intended to be on top of each home to produce electricity. And each unit produces more electricity than it consumes. So having that backup storage in the community center was beneficial.
And so how is it that it's going to actually get built?
So Shelly's been working really closely, and Shelly's my professor from Prairie View. But she's been working with the city, has some contacts, and really been pushing this project, asking everybody for help. And everybody that we ask for help always likes to listen and contribute more ideas. So right now we're trying to get lots from the city. And once we do get those 2 lots, depending on where they will be placed, then the funding can come in. And Phius is also partnering to help out, as well as other folks that are very interested in donating. Of course, to make this work, since it is going to be a city project, using city funds in order to make it Phius and actually have all those performance and efficient equipment, we probably will be needing many donations, like windows, the mechanical equipment, all of the special things that make it high performing and not just a traditional city built home.
Great. Well, that would be an exciting project to have happen.
Yes. And it'll serve as an educational piece too to the community, because, once we built it and it is a Phius certified home, builders can come look at it. Any trades can come see what we did differently here, what was needed to make it airtight, and also allow other subs to work on the home. The health and wellness component, the grid, the microgrid on the community. There's a lot of educational pieces in all parts of the design.
That's great. And one thing that was brought up yesterday was resilience. Was there particular aspects of the design that were focused on resilience features?
Yes, the student design that won the competitions was elevated 4 feet above the ground, which now in Houston, any home that's built in a floodplain needs to be elevated 4 feet or designed 4 feet above. The fly flat has two roofs, so just the thermal boundary roof and then an additional overhang roof that's about a foot above the original roof structure to block the extra sun, reflect it. So that provides shade. The original design also had like Sujibon wood that's termite resistant and very durable. And the mechanical system and windows, all of those upgrades to the envelope really help the interior be resilient and offer the homeowner like cheaper utilities. So that also adds to the resilience piece where they can afford to live there and it'll be a healthier home. The microgrid can be really flexible, but our design intended the microgrid solar to be used as a way to generate passive income to sell back some of that electricity. So resiliency is really important. And then with a durable home, in the case of a hurricane, you don't have to start all over, which is sort of the reason how this project generated, where in Independence Heights, many homes were vacated because they had never recovered from hurricanes in the past, whether they didn't get funding or whether there was other factors. We're trying to prevent someone to have to start over.
That's great, yeah, because we know there's more hurricanes coming, unfortunately. Yeah. Great. Well, thank you so much for your time. I really appreciate you stopping by to talk.
Thank you, Mary.